Good morning, everybody. I am Professor Swam Reddy from SR University. Today we are going to discuss the continuation of inverse Laplace transform. In lecture 5, we discussed the inverse Laplace transform of integrals, derivatives, change of scale property, first shifting theorem, and second shifting theorem. Right? These topics in previous lectures we discussed. So in this lecture, I'm going to introduce the inverse Laplace transform of multiplication by S, right? Multiplication by S. So what is multiplication by S? So you see the Laplace transform of f of t is f bar of S, or the inverse Laplace transform of f bar of S is f of t. Then the inverse Laplace transform of S into f bar of S multiplication with S is equal to f dash of t first order derivative or dft by dt, right? Derivative of f of t with respect to t, where f of 0 is 0, right? The function value at 0 is 0. So how we write this formula? We know that the Laplace transform of derivatives, first order derivative, second order derivative, third, nth order, we discussed in previous classes. Now, the Laplace transform of f dash of t is equal to s into f bar of s minus f of 0. But here f of 0 is 0, it is given that. Therefore, the Laplace transform of f dash of t is equal to s into f bar of s. Now next, inverse Laplace transform. The inverse Laplace transform s into f bar of s is f dash t. That's multiplication with s inverse Laplace transform plus differentiation of f of t with respect to t. Now we are going to discuss some examples on inverse Laplace transform of multiplication by s. See here the first example. Sorry. Find the inverse Laplace transform of s by s square minus a square. We know that this is already the inverse Laplace transform standard functions. This inverse Laplace transform of we discussed s square minus a square is cos hat. Simply we know this cos hat. Now by using multiplication with s, how you evaluate? Just you take this, rewrite this equation, inverse Laplace transform this s into 1 by s square minus a square, right? This is in the form of inverse Laplace transform of s into f bar of s. So what is f bar of s here? F bar of s is 1 by s square minus a square, right? Now, from this you calculate f of t. What is our formula? The inverse Laplace transform of s into f bar of s is equal to f dash of t. First you calculate f of t and make derivative with respect to t. So the inverse Laplace transform of f bar of s is this is f of t. Both sides apply inverse Laplace, right? Let's write down inverse Laplace transform f bar of s and inverse Laplace transform 1 by s square minus a square. This is f of t. What is this? This is 1 by a into sine hat. Sine hat, right? This is f of t. Now from formula, multiplication with s formula, s into f bar of s inverse Laplace transform f dash t. Now differentiate this. So d by f dash of t is equal to d by dt of f of t 1 by a into sin h a t, right? So is a 1 by a is constant. Sin h a t derivative is cos h a t into a. So a gets cancelled. So this is equal to cos h a t. Therefore, the inverse Laplace transform s by s square minus a square is cos h a t using this multiplication with s formula, right? And next example, if you see, this is a simple inverse Laplace transform, and this one is find the inverse Laplace transform of s by s plus 2 whole square plus 2 square or 4, whatever to take, right? Now let's just write this in the form of s into this inverse Laplace transform of s into 1 by s plus 2 whole square plus 2 square, 4 square is 2 square, close. So what is here f bar of s? F bar of s is, right, 1 by s plus 2 whole square plus 2 square. This is f bar of s. 2 square or simply write on 4, whatever. Now find inverse Laplace transform both sides. So inverse Laplace transform f bar of s is equal to inverse Laplace transform 1 by s plus 2 whole square plus 2 square. Now this is f of t, right? Not f bar, f of t, simply f of t. This is equal, by first shifting theorem, just you write down this is e to the power of minus 2t, because s is replaced by s plus 2. So first shifting theorem, write down e to the power of minus 2t into inverse Laplace transform 1 by s square plus 2 square. What is this? This is e to the power of minus 2t into here 1 by 2 into, right? This is 2 square now. Sine 2t, sine 2t, 1 by 2 into sine 2t, right? Now f of t is this e to the power of minus 2t by 2 into sine 2t. Now differentiate this f dash of t, f dash of t equal to, here 1 by 2 is constant, right? D by dt of e to the power of minus 2t into sine 2t, sine 2t. So this is, both are functions of t, both are functions of t. Assume this is u and this is v. U dash v, what is the formula of u into v? U into derivative of u into v is, right, u dash v plus uv dash. This is the derivative formula. And next is, so apply u into v formula, u dash v plus uv dash, right? So what is this? This is 1 by 2 into 1 by 2 into d by dt of e to the power of minus 2t sine 2t, right? So this is equal to d by dt of, first differentiate this, keep this is constant. So e to the power of minus 2t is derivative is here half into minus 2 into e to the power of minus 2t, right? Sine 2t is keep constant, place keep e to the power of minus 2t constant, and sine 2t is cos 2t into 2, right? U dash v plus uv dash. Now after simplification, this 2 gets cancelled now. 2, 2, and here also 2 gets cancelled. So this is equal to, final answer is e to the power of minus 2t cos 2t, right? Here minus is, right, e to the power of minus 2t common, sin 2t. This is the final solution. And next is, let's take this s square by s square plus a square whole square. Find inverse Laplace transform of this. So just rewrite this. This is equal sorry, inverse Laplace transform of this s into f bar of s. Here f bar of s is, what is this? S by s square plus a square whole square. Now find f bar of s is s by s square plus a square whole square. Now apply inverse Laplace transform. Both sides, f bar of s is equal to inverse Laplace transform s by s square plus a square whole square. This is f bar of s is simply f of t. Now s by s square plus a square whole square is by, this is actually s by s square plus 2as. You know this formula, the Laplace transform of the Laplace transform of t sin at, t sin at is equal to 2as by s square plus a square whole square. This is the actual formula. Now the inverse Laplace transform of this s by s square plus a square whole square is equal to, what you say, is 2a, send that side, t by 2a, right? T by 2a sin 80. That's what I wrote this here. T by 2a sin 80. Now 1 by 2a take out here. This is nothing but t by 2a sin 80. Inverse Laplace transform this s by s. Now differentiate this t by 2a sin 80, differentiate. Once again, this is 1 by 2a, f dash t is equal to 1 by 2a into t sin 80, t sin 80. This is u and this is v. So u dash v plus uv dash, u dash v plus uv dash, right? So what is t? Derivative of t with respect to is 1. Sin 80 derivative is cos 80. Next, sin 80 keep constant. What is the derivative of t? 1. So this is equal to, right? This is the inverse Laplace transform of s square by s square plus a square whole square is equal to 1 by 2a t cos 80 into a plus sin 80, right? Similarly, we can find this s square by inverse Laplace transform of s square by s minus 1 whole cube, s minus 1 whole cube. First you write this inverse Laplace transform of, write s into this s by s minus 1 whole cube. This is equal to inverse Laplace transform of s into f bar of s. Here what is f bar of s? F bar of s is, right, here we have to apply 2 times here. 2 times apply here. Here s square by s minus 1 whole cube is there now. First you take is s into this s. Here f bar of s, 2 times you apply because s square is there, right? First here s into f bar of s is equal to f dash of t. Here f bar of s is 1 by s minus 1 whole cube. We will take. First take 1 by s minus 1 whole cube, right? Because this is equal to, first I am considering this s by s minus 1 whole cube. Next, 2 times taking derivative, then s square by s minus 1 whole cube we can get. So here first f bar of s is equal to 1 by s minus 1 whole cube. Now apply inverse Laplace transform on both sides. This is equal to inverse Laplace transform 1 by s minus 1 whole cube by first shifting theorem. This is straightforwardly f of t, inverse Laplace transform. F bar of s is f of t, right? And next is by first shifting theorem, just you write down it is e power minus t into inverse Laplace transform 1 by s cube. Inverse Laplace transform 1 by s cube is t square by 2 factorial. T square by 2 factorial. So what is say f of t is equal to e to the power of t into, right? Here minus is there, sorry. So you would get plus. S is replaced by s minus 1 only e to the power of t, right? And next is this e to the power of t, t square by 2 factor. This is f of t. Now the inverse Laplace transform s into f bar of s is d by derivative, first order derivative of this t square into e to the power of t. Right? Once again u into v method apply, u into v. So this is t square derivative is 2t, e power t is constant, and plus e to the power of t derivative is e to the power of t into t square is constant. So this is the inverse Laplace transform of s by s minus 1 whole cube is equal to half into, right, 2t e to the power of t plus e to the power of t into t square. This is only s by, but we need the inverse Laplace transform s square by s minus 1 whole cube. So now write down this is inverse Laplace transform s into s by s minus 1 whole cube. What is s inverse Laplace from here? Here s into f bar of s, s into f bar of s, right? So f bar of s is the inverse Laplace on f bar of s. Already we get this here. What is this? This one, f of t9. Already we obtained this. So once again you differentiate this. Once again you differentiate this because s square is there. So half into derivative of this 2 t e to the power of t. So t derivative is 1 e power t plus 2t e to the power of derivative is e to the power of t plus this one e to the power of t derivative is e to the power of t, t square keep constant. Next e to the power of t keep constant, t square derivative is 2t. So now let's simplify. C is equal to 1 by 2 e to the power of t take out, right? What do we get here? T square plus 4t plus 2. So the finally the inverse Laplace transform s square by s minus 1 whole cube is this one. So 2 times we have applied the multiplication with s formula. 2 times apply because s square is given. If you take f bar of s is directly s by s minus 1 whole cube, you can't get this. Once again this you assume this is 1 by s minus 1 whole cube s into. So 2 times repeat the formula. This is about multiplication with yes formula, right? Next, division by yes formula, right? In division by yes, you know the inverse Laplace transform of f bar of s is f of t. Then inverse Laplace transform f bar of s by s division by s is equal to integral 0 to t f of t dt or f of u du. Right? Inverse Laplace transform division by s f bar of s by s is equal integral 0 to t f of u du. That's all. How we get this? You know the Laplace transform of integrals. Laplace transform integral 0 to t f of u du is equal to f bar of s by s. So from this directly we can write inverse Laplace transform f bar of s by s is 0 to t f of u du. That's all. The Laplace transform integral formula, from Laplace transform integral formula we obtain inverse Laplace transform division by s formula. Division by s formula. Right? Now let's go to the examples on division by s formula. Here, find the inverse Laplace transform of this 1 by s into s plus 3. Right? Just you write down this division by s formula. This is equal to inverse Laplace transform 1 by s plus 3 by s. This is equal to, in the form of inverse Laplace transform, f bar of s by s. Right? Here s by 1, then you get same, right, fraction. So f bar of s by s. So what is f bar of s here? F bar of s is, what is that? 1 by s plus 3. Now the inverse Laplace transform apply both sides. F bar of s is equal inverse Laplace transform 1 by s plus 3. So this is equal to f of t, right? This is equal to e to the power of minus 3t. F, right? Now the inverse Laplace transform of this 1 by s into s plus 3 is equal to integral 0 to t f of t dt. So what is f of t here? 0 to t f of t is e to the power of minus 3t. E to the power of minus 3t dt. That's it. Now integrate this. E to the power of minus 3t integration is, what do you get here? E to the power of minus 3t by minus 3 integral 0 to t limits. So this is equal to reveals e to the power of minus 3t, right, upper limit by minus 3, lower limit e to the power of 0. So the 1 by 3, right? 1 by 3. This is 1 by 3. So this is equal to, right? Your minus is there now. So this is equal to 1 minus e to the power of minus 3t by 3. Right? This is about upper limit minus lower limit. This is about division by s. Similarly, if you take this one, 1 by s into s square plus a square. Then write down this. The inverse Laplace transform 1 by s square plus a square by s. This is inverse Laplace transform f bar of s by s. What is f bar of s here? F bar of s is 1 by s square plus a square. Apply both sides inverse Laplace transform. Inverse Laplace transform both sides. So this is f of t. What is this? 1 by a into sin a t. 1 by a into sin a t. Now apply division by s formula. The inverse Laplace transform of f bar of s by s is equal integral 0 to t f of t dt. What is f of t? This is equal 1 by a integral 0 to t sin a t dt. What is the derivative of sine integration of sine 80? Cos 80, right? Sine 80 integration is minus cos 80, right? So minus cos 80, 0 to t, 0 to t. Substitute limits, right? Minus 1 by a cos 80, cos 80, cos 0 is 1. So this is equal 1 minus cos 80 by a square, right? Integration of sin 80 is minus cos 80, right? That is minus 1 by a upper limit t is equal to cos 80, lower limit cos 80 is 0, right? Cos 0 is 1, sorry, cos 0 is 1. So minus here 1 minus cos 80 by, right? And cos 80 by, already is 1 by a, so a square. That's cos 80 by. This is about division by s formula. Now next example is inverse Laplace transform of s plus 2 by s square into s plus 3. S square into s plus 3. First you separate this. Separate the fractions. This is equal to inverse Laplace transform s by s square into s plus 3 plus inverse Laplace transform 2 by s square into s plus 3. That's all. First you take this, here s gets cancelled. So this is equal to inverse Laplace transform 1 by s into s plus 3. 1 by s into s plus 3. This is equal to what you write here? This is equal to first one consider 1 by s plus 3 by s. This is equal to inverse Laplace transform f bar of s by s. What is f bar of s? Here f bar of s is 1 by s plus 3. What is f of t? Both sides apply inverse Laplace transform. F of t is equal e to the power of minus 3t. Right? Now integrate this as per division by s formula. Inverse Laplace transform division by s. F bar of s by s is equal to integral 0 to t f of t dt. So this is equal to integral 0 to t e to the power of minus 3t into dt, and this is equal to e to the power of minus 3t by minus 3, 0 to t. Substitute limit, upper limit minus lower limit, what we get? This is equal to 1 minus e to the power of minus 3t by 3, e to the power of minus 3t by 3. This is the first one. Similarly, second one, you can take second one. This is inverse Laplace transform 2 by s square plus s plus 3. So a 2 constant. So this is equal to what we take here? This is inverse Laplace transform of 2 keep SIR 2 by s square into s plus 3. So this 2 take out, inverse Laplace transform is 1 by, we can write this s into s plus 3 by s. If you send s here, s square into s plus 3, just rewrite this s square. Already we calculated this. We calculated in the previous one. What is that? F bar of s, here f bar of s is 1 by s into s plus 3. So both sides apply inverse Laplace transform, that is f of t is equal to, in the first one we calculated now, so that is 1 minus e to the power of minus 3t by 3 f of t, right? Now Once again we integrate, two times we apply for this one. So once again we integrate this. So this is equal to inverse Laplace transform of 2 by s square into s plus 3 is equal to 2 into integral 0 to t 1 minus e to the power of minus 3t by, right, 3. Now 2 times integrate this, right? Right. So finally what we get here? This one. Integrate and substitute limits. And similarly, you can so what we discussed in previous topics. So the inverse Laplace transform derivatives, inverse Laplace transform integrals, division by s, and multiplication of these topics we discussed. So thank you very much.